Hey guys, welcome back to another Tutor Toby video. So for today's video, we'll be going over two different topics. So the first is going to be how to use the integrating factor method to solve first order ordinary differential equations. And then our second topic is going to be how to use the Laplace transform to solve these ordinary differential equations. Okay, so first off, we'll be going over the integrating factor method. So what this method is we have y prime plus some, let's just call it f of my function t times y is going to be equal to some other p as a function of t. Okay, so if we have a function in this form, we can actually use an integrating factor, which is equal to e to the integral of f of t dt. So if we do this, we multiply this on both sides, times the group y prime plus f of t times y equals e integral . Okay, and why we do this is because it allows us to really easily simplify this. So we note that this is just the same as d dt of the group e to the integral f t dt times y. And this side obviously just stays the same. So we'll duplicate it, and then to get rid of d dt, we can just slap an integral on both sides with respect to d dt. So now we get e to the integral ft dt times y, and our y is a function of t, is equal to integral of e f of t, this integral dt times p of t. And then to solve for y of t, all we have to do is divide by this term right here. Cool. And then this is our solved differential equation. So now let me go over this step right here in just a little bit more detail, because I know the first time people see this, they're like, whoa, 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 how did you just pull a DDT out and get that inner group? So just to like show that this is true, I'll just do this actual derivative here that we have written down in the highlighted section above. And remember that t is, or y is a function of t, so I'll write it specifically like this. So this is going to be product rule, so I'll say u prime times v plus v prime times u. I don't know how you guys remember it, but that's how I remember it. So now my u prime is going to be e integral ft dt times the derivative of the top from chain rule. So we have d dt of the integral with respect to time, which is just going to be canceling each other out, giving me f of t, and then my v right here is just going to be my times y of t, and then we have derivative of y of t is going to be dy over dt, right? And then my u is the same, integral f of t dt. Okay, so now we actually see that we can pull out this term and this term, which leads us with e to the integral f of t dt times the group. I'm going to put this term first. Remember that dy dt is the same as y prime. And then we have plus this term right here. So that's going to be f of t times y. And as we can clearly see, that is indeed the same as we have here. So this is directly equal to this. t dt times y. So now let's just go over a few example problems, because I know that derivation above can look a little abstract. So let's have y prime plus 1 over t plus 1 times y equal 2. And let's just give it an initial condition. So y of 0 is equal to 0. Okay, so this is my p as a function of t. So that means my integrating factor is going to be equal to e to the integral 1 over t plus 1 dt. Okay, so now we know that the integral of 1 over t plus 1 is just equal to natural log of t plus 1. And then we see the natural log and the e just cancel out, leaving us just with t plus 1. Okay, so now just kind of following the formula of this problem, we multiply our integrating factor on each side. So we do t plus 1 times the group y prime plus 1 over t plus 1 y equals t plus 1 times 2. Okay, we then know, just because it's an integrating factor method problem and it was in this specific form up here, we can do d dt of y times t plus 1. So this is my integrating factor. And that still just equals the other side. So I'll write it like this. And now to get rid of d dt, we can just slap an integral on each side. So this goes to y times t plus 1 is equal to t squared plus 2t. And this is the indefinite integral, so we add in a plus c here. So now we get the simple equation y equals t squared 2t c all over t plus 1. Okay, so now we plug in our initial conditions from up here. Bring that down. So we have 0 equals 0 plus c all over 1, which then clearly leads to c equals 0. So our specific equation with these initial conditions is just this. Okay, so now for a second example problem, we'll do y prime minus y equals e to the 3t. So again, we see that this is in the form y prime plus p of t times y equals f of t. And in this particular case, my p of t is just equal to -1. Okay, so now we say integrating factor is always our first step. So that equals e integral -1 dt, which just equals e to the negative t. And then our second step is always multiply integrating factor, which then goes to e negative t y prime minus y equals e to the 2t, right? Because this is just equal to 3t minus t. Okay, so now we say d over dt is equal to e negative t times y. That's my integrating factor, is equal to the other side stays the same. Integrate. So integral d over dt e negative t times y equal to integral e to the 2t dt. For this side, we see that those two cancel out. And then we get e to the negative t times y equals 1/2 e to the 2t plus c, which then leads to our y as a function of t is just equal to 1/2 e to the 2t divided by e negative t plus c over e to the negative t, which I'll simplify this first term really quick. So that's just equal to e to the 5/2 t all over 2 plus c over e to the negative t. And this is our final solution, where if we were given initial conditions, we could solve for our c. Alright guys, I'd like to go over one more example problem, and this is kind of a more fun example problem. So let's consider the equation y prime plus t times y equals ty cubed. So this isn't quite in our form where it's like this, because we have this extra y term right here. So what we do in this case is let's divide by this y term on each side. So we get y prime over y cubed plus ty to the negative 2 equals t. Okay, so now we say let v equal y to the negative 2, so this part right here, which then leads v prime is equal to y to the negative 3 times y prime. Okay, so now that we have this, we can see that this v prime term is the same as right here, so that goes to v prime plus, and then it's just tv equals t. And now this is actually in the form that we want, which is v prime plus some p of t times v equals some other f of t. And now we can just apply our integrating factor method. So we say let our integrating factor be equal to e to the integral of t dt, which equals e to the 1/2 t squared. Okay, so we multiply this on both sides. E 1/2 t squared v prime tv 1/2 t squared times t. We then remember the cool trick of integrating factor method. Which is this. Now we can slap the integral on both sides, which we're left with v e to the 1/2 t squared equals e to the 1/2 t squared plus a constant c. So I get this by just using u substitution, which is equal to t squared. So du is equal to 2t dt, which then goes to integral e to the, let's just slap in a 1/2 right here to get rid of that. So this is going to be u, and it's going to be du, which just equals e to the u, which equals e to the 1/2 t squared. And then we always add the plus c. So now we get v is equal to 1 plus c over e to the 1/2 t squared. And now from above we have our v defined right here. So then we get y, I'll do 1 over y squared, is equal to 1 plus c over e to the 1/2 t squared. So then we can multiply and divide and get y equals plus or minus square root of 1 over this whole group right here. And then we can always solve for this constant c given an initial condition. Alright guys, so that's all that I have for you today. I decided not to go over the Laplace transform in this video. That'll be gone over in the next video because this video is getting a little bit long. So remember to like, share, and subscribe. If you enjoyed this video, make sure to give it a thumbs up. And I will see you on the next video for Laplace transforms.